Hi there. This is the first video for the labs. There'll either be 2 or 3 videos total. First, just the basic how the circuit that you're using in lab works this week. What I have on the screen right here is the basic differential pair. Actually, sorry, in EE308 it's a differential pair. In EE307 it's called an ECL or a PECL. And with an ECL, this isn't VDD, it's ground, and then this is a negative voltage. But these days that doesn't really make sense on a chip, so it's not, ECL is not really used. But whether this is VDD up here and this is ground down here, or whether this is VDD and ground here, or ground up here and minus VDD down here, it really doesn't make all that much difference to the functionality of the circuit. It still operates the same. So let's look at that. So I know in your lab manual you have a resistor here, but just believe me for a second that it's acting something like a current source. So you have some current going down here. Let's call it ISS. Okay, kind of traditionally called ISS, or actually, so that's from MOSFET. So I guess officially this IE, which is in the lab manual, is more appropriate since it's current coming out of the emitters of Q1 and Q2. So you have this current. So let's say VI plus equals VI minus. So the base of Q1 and the base of Q2 have the same voltage. If that's the case, and these R's are the same, so the transistors are the same, the R's are the same, the voltages on the transistors are the same, that means they're both going to be conducting the same amount of current, which is IE over 2 on this side and IE over 2 on this side. Okay, that's only in the case when VI plus equals VI minus. Okay, and let's figure out, just while we're here, okay, if I have IE over 2, the value of V out, let's do minus, that means that V out minus, this is VDD up here in this particular example. I know in the lab manual that's ground, but for VDD, it would be VDD minus your I, which is IE over 2 times R. And that gives you your V out. And because the currents are the same, in this case, that equals V out plus. And green is VI plus equals VI minus. And this VI plus and VI minus has to be somewhere kind of in the middle between VDD and ground. In this case, somewhere maybe around VDD over 2, something like that. But one of the great things about this circuit is it really doesn't care. As long as you leave enough space for V out to go down. So if VI was VDD, then that's a little tight. Then V out can't swing very much without putting Q2 into linear mode. Okay. So yeah, so very often it's somewhere in the middle, but it has a wide range here that your VIs can be. Okay, so let's change colors here. Let's do one where so blue is, say, VI plus is, let's say that you raise it, so you add some delta V. Okay, so let's keep VI minus constant. VI minus is what it was before, no change. Okay, so now we've raised VI plus by delta V. Notice that the emitter for Q2 and Q1, they're shared. That's actually where the name comes from. ECL is emitter coupled. In other words, the emitters are see, emitter coupled means the emitters are tied together. Okay, so now if I raise VI plus some amount, the voltage, the VI didn't change, so there's some VBE on both of these. But notice, since they share the same E, if I raise VI plus, now the VBE on the VI plus side is going to definitely be bigger than the VI minus side. So let's say this equaled 2 volts and this equaled 2.5 volts or something like that. They both share the same emitter. Remember, VBE equals VB minus VE. And since the VEs are the same on both sides, but the B's are different, definitely the BE on the plus side is larger. And you have IC equals IS e to the VBE over VT. Since this is exponential, when VBE just goes up a little bit, the current goes up like mad. So what it does here, when the inputs were equal, you had the equal amount of currents on both sides. But now, when you just change VI plus a little bit, what happens is that it exponentially wants to turn up its current. And so it steals it from the right side. And now, pretty much all of the current will go through this side. And this I equals 0 over here. Because just changing this VBE a little bit turns up the current so much, what happens is the current gets steered over to the left side. So this is a current steering logic family, and it pulls the current over to the left side from the right side. It's still the same amount of current going through the circuit. This tail current source is called a tail current source. It's constant. The only thing that changes is whether that current is going through the left side of your circuit or the right side of your circuit. And when VI plus is greater than VI minus, the current goes through the left side. When VI minus is greater than VI plus, then the current goes through the right side. Did I say that? So VI plus greater than VI minus, it goes through the left side. And VI minus greater than VI plus, current goes through the right side. And that's the basic of current steering logic. And in current steering logic, there's ECL and PECL, which PECL is, MCML, which is MOS current mode logic, which is this exact same circuit except using MOSFETs, is pretty common these days. It's becoming a popular logic family. ECL, not so much. That negative rail really isn't something that's nice to design with these days. PECL is more of, if in either one is used, then it's PECL. That's the basic operation of this. If VI plus is greater than VI minus, current goes to the left side. And if current goes through the left side, okay, I hope it's a big point here. Okay, if current is going through the left side, then your V out minus, now all of your current's going through your left side, so now it equals VDD minus IE times R. And then V out plus, that, since there's no current going through that side, V out plus basically equals VDD. Okay. And your output is not rail-to-rail swing. This V out minus does not equal 0. Okay. Yeah. Okay. And so when you raise VI plus, V out minus goes down. When you raise VI minus, then V out plus goes down.